In this optimization problem, we are going to solve the problem of biggest rectangle inside a circle. So we do have a rectangle with radius r, and we want to find out what is the maximum area of a rectangle inside that circle. So in order to solve the problem, we have to formulate it mathematically. Now let's talk about how we can do this. Suppose this side of the big rectangle is x, this one is x, this one is y, okay? And then the surface of that rectangle will become 4 times x multiplied by y. And also we do have some other constraints that should be written. The x value is something between minus r and r. And also y square plus x square is equal to r square. Okay. Now we want to find out how can we solve this problem. Hello everybody, this lecture is going to be talking about the problem of biggest rectangle inside a circle. Suppose we have the following optimization problem and we want to formulate it as an optimization problem. We want to know what is the maximum area of a rectangle inside a circle. So suppose we do have this graph, we do have a circle with radius r, and we want to know how can we find the maximum area of that rectangle. This side is x, this side is y, and now we want to find out what is the area of the whole rectangle. So it will be obviously 4 times one of these small rectangles. So 4 times x multiplied by y. Obviously you can see on this graph x can move between 0 and r at maximum, and also y is doing the same. It is moving from 0 to r. Then we do have a relation between x and r because they are all on the circle. Then x square plus y square is r square, and the other two constraints are given as follows. X is between 0 and r, y is between 0 and r. Okay, in order to solve it in Python, we need to define some input data and also some decision variables. Now you can imagine what are the decision variables here. So we have 2 decision variables, x and y, and also one objective function, which is called OF here. Then we need to find out how can we write down the equations describing the objective function, how can we define the decision variables, and how should we define the limits of the variables, and how can we finally solve it. So please refer to your Python code as you can see in the attachment. Then let's solve this all together. Okay, so here you can see that we have formulated the problem here in Pyomo. Let's start with the first tab. The code is written in Jupyter Notebook and it can be easily run on your machine. It can be a MacBook or a Windows based kind of machine. So first of all, we import the Pyomo package using this command from pyomo.environ import asterisk. It means import everything. So these are the comments to find out what's going on. Okay, so these are not going to change anything on your formulation, but just give you some hints what's happening. Okay, so for this example, I'm going to use the concrete model Then using the data that we have for this problem, I'm going to initialize it. Then, for example, r is a parameter because we know the value of it initially, and we initialize it with number 10. You can choose any other number that you want. And then x is a variable, so model.x is equal to var. Bounds are specified here. It's moving between 0 and model.r. Don't write down r because it doesn't recognize r. It only recognizes model.r, which is already defined. And we can initialize it with some value. I have chosen model.r as the initial value. Model.y variable again, and the bounds are the same between 0 and r. And we have initialized that with model.r. Then I do have a constraint C1. Constraint is equal to constraint. Expression is which is describing the model is equal to model x square. I've written the square in this way, and also model.y square is equal to model.r square. And finally, the objective function is equal to expression 4 times model x multiplied by model y, with the sense of maximization, because we want to maximize the objective function. Then on the next tab, let's run the tabs individually. The first tab is run, okay. The second tab is done the same. On the third tab, I'm going to define the solver I'm going to use for solving the problem. Let's have a look at the shape of the optimization problem. It has a multiplication of x by y and it becomes nonlinear. So I have to use a nonlinear kind of solver. So for this purpose, I have used IP_opt. Solver is specified here. Solver is equal to solver factory IP_opt. And the results is equal to solver.solve name of the model, and I have chosen the model. Okay, you could use any other kind of naming. And then let's run this tab. So this tab is already run, and then the simulation is finished, and I do have the values for the x and y. So if I run it again, you can see the values of x and y equal to each other, equal to 7.071, and the amount of objective function is 200. And also I can get some other results from the simulation. If I run this, I can get some other results. I can fix one of the variables. For example, I can fix one of the variables like x equal to something, which is 1 here, which can happen for you. For example, you want to have a fixed variable in your model and you already know the value, so you can fix it and solve the rest of the problem. So with x equal to 1, y becomes something else and objective function is something else. So by comparing these two simulations, you can see by manipulating the decision variables, you are getting them far away from the optimal value they can get. So the optimal value for x and y are equal to each other, equal to 7.071. But if you change that and fix some of them, the results become something else. Okay, so in order to unfix the decision variable and fix something else, you can use this command model.x.unfix. It means that the variable x is no longer a fixed value, and you can fix something else, or you can't. You can do nothing. Okay, and then solve it again, and you can see the results here. This time y is equal to 1. And x is something else. Okay, and the objective function is found. You can unfix everything, okay, and then solve the problem again and see the results. Okay, so here you can see that there are some useful information regarding the model you have solved: the number of constraints, the number of variables, the objective function, the bounds for everything is found, and also it tells you that the solver has been successful in finding the optimal solution or not. Okay, so you can expand this model to any other application if you want, and that's it for this session.